story of Ethernet is best told in personal stories, shared by its very own creators, producers, and users. The Voice of Ethernet archive is dedicated to preserving the oral history of Ethernet through spoken records and interviews with the individuals engaged in the technology's global emergence as the foundation of the Internet. Today, I'll talk with Gary Robinson, one of the people behind Ethernet stories, to hear his account and experience with some of the important milestones behind the technology's history. So, Gary, thank you so much for joining us today. Could you please, in a short fashion, introduce yourself?
Yes, my name is Gary Robinson, electrical engineer. I started work at Bell Laboratories in 1961. And in 1980, I moved to Digital Equipment Corporation. And within 1 month, I got involved in what became Ethernet IEEE 802. I represented the three companies, Digital Equipment, Xerox, and Intel, in standardizing what became Ethernet. I say what became because for years it was CSMA CD, and it was only later we officially were able to change the name to Ethernet. So I've been in standards since the middle of the 70s, and that's I guess, the most important part of my life with respect to Ethernet.
So you showed up to DEC and you immediately got assigned to standards, right? What did you do wrong?
I did not know what a LAN was. My manager came to me and said, would I be willing to do it? I was new, so I said yes. And I learned what a LAN was from then on. But I was in standards and I knew how to, let's say, negotiate. I was willing to go to conferences, something other engineers sometimes don't like to do. I enjoyed working with people, and it turned out to be a natural fit. So
it's sort of interesting because your involvement started not being an expert on the technology, but being a practitioner of the standards world.
Yes. My previous experience was standardizing magnetic tape interfaces for magnetic tape drives, which in those days was the main memory of a computer. Disk drives were not there yet. And I really enjoyed the interaction with people, and I had enough technology background. I mean, I was supposedly an engineer. I had enough background to do both, get accepted by the technical people, but yet deal with them as people. I was very fortunate a long time ago, 59 years ago, of marrying my wife, Natalie, who eventually, after being a school teacher, turned out to be a psychotherapist. And I'll tell you, before and after every Ethernet meeting, which was like every 2 months, I would sit down and go over, not the technical details, but what was going on. And she treated the 802 group as a, let's say, dysfunctional family, but it was a family. And I learned a lot. She taught me a lot, and it has helped a lot. So I guess my personality fit into doing the work I ended up doing.
So you are more of a people person and a organizational person than a technical expert.
I agree with you. I did not start out that way, but I must, marriage made a big change, and I became a technical person less and less, and a people person more and more. And it must have been right because I really enjoyed it. I really liked what I was doing.
What was the response from the very highly technical people you were around? How did they relate to you?
Most of them did not know my background. I was the kind of person that would sit in the back of the room and sort of tell our people, what to do. I very carefully would not take the chair. I got Don Lockery to do that. I would not take the secretary. I wanted to be in the back. I wanted to move around. I wanted to talk to people. I wanted to keep things going. And
That sounds like a very familiar role. I've done that myself a bit.
I'll tell you, I went to a meeting. I forget what country we're in, and a few of the leaders.
Yeah, I've done that as well. It's like which country
a few
were
of
we
the
in?
leaders. A few of the leaders, and because it was a distance and it was a very nice place, my wife was with me, and one of them, Jeff Thompson, very involved in this project, he said, "Bring Natalie to dinner. I want to know what her feeling is about so and so and so and so and so and so." And I'll tell you, more than once, she came with us and other people brought their wives. And the idea was they understood, I wouldn't say that she could analyze people, but her view would be very helpful to us.
So Gary, what you're really saying is that there's this role, and people wouldn't think about it, which is aside from the technical discussion, right? There's the key thing about understanding what other people want to achieve and how they want to do it.
One can have a technical discussion, and we've had some very interesting technical discussions of which I didn't necessarily participate, I listened to. But what my job was, and I always made this clear to the other people I was working with, the objective was to make Ethernet into a standard, not to make ourselves feel good that we won an argument or any of those things. Keep in mind the objective at all times. And that meant we had to understand what the objective of the other people was. And we couldn't figure that out for all of the 350 people that were attending. But what were the key players? And why are some of them, and the ones who are helping us were not the issue. It's why were the other ones, doing what they were doing? Why were they making things so difficult? And I would bring this home to my wife, and she would discuss them as the father figure, the siblings, this one and this one. I'll tell you, I understood.
Which role is being played?
Yes. And she clearly explained it as a family. I can assure you I did not understand a great deal, but it helped in the long run, helped a great deal.
That makes a lot of sense to me. And if we go that thing, when ADA 2 started, right, there was the conversation between the CSMA-CD people, the token bus people, and the token ring people. And they're all trying to get theirs standardized as the one thing. And I believe when we became dotted, right, your wife had a bit of role in that as well.
Yes, it started out where at the beginning, the Maris Grauby, who actually started this whole thing, he was trying to get a local area network, and he had heard about the work that Xerox and Digital Equipment were doing. And he was really, I think, trying to get that surfaced and maybe even made into a standard. But once that started, then the people doing token ring, IBM, said, well, we can't have, Ethernet, we have to compete. So they got involved, and then Token Bus got involved in that also. So it became a competition between the three. And what I realized after a while was trying to compete between the three, we may not win. We're too small. And remembering the objective is to get CSMA CD Ethernet made into a standard, I ended up writing a motion and then handing it off to somebody else who was on much better terms with the chair of that particular committee. And the motion was that all three should exist. And it took quite a while because it turned out to be the key motion. And at the end, it was approved that all three should exist. So the only competition left was when they were going to come out. Was one going to come before the other, and so on. But then in that, who was going to be first, one was trying to hold up the other. My wife helped. And what she said was, you ought to reframe it. And I asked her, what does reframing mean? And she explained that to me. I won't try to explain it to you because I really don't understand. But I was able to implement what she wanted, even though I didn't understand it. I was able to implement it. And at one pre-meeting, I suggested to the CSMA group that what we ought to do is break up. And it turns out that, I don't know how it came about, but 802, let's do a .1, .2, .3, .4, .5. And so .3 became CSMA-CD, .4 became token bus, and .5 became token ring. .1, I had to give the current chairs and the current big shots a job, so I invented the executive committee. People were angry for me about that for years, but in any case, changing it from 802, where it was a brawl between all these people, to separate them, friendly, and with an agreement that we will not attack each other. And that was another key to it. So we formed, that's how the dot committees got formed. And we were then able to go on from there. And even though we were a little ahead of Token Bus, I assured the chair of Token Bus, this great fellow, Bob Donnan from IBM, that we're not, even if we get approved before Token Ring does, we were not going to hold them up or anything like that. We were working side by side. And so that allowed us to move forward.
So you figured out the set of groups, the native set of groups, and told them they could go out and work to solve their needs instead of trying to make one size fits all.
And I would have, yes, I would have liked to have one size fit all and it be me. But let me tell you, at this point, I didn't think it was going to be me if it was one size fits all. I mean, at the time, Digital Equipment was a great company, but not as great, as big as IBM was. They were very professional and very competent. And how do you become equal with them? How do you get yours to be a standard? You have to work together. And my wife suggested a way of doing it. I implemented it. Other people followed. But anyway, it's the 30th anniversary shirt. And what's interesting, when I went to the 30th anniversary, I was on the same plane as Bob Metcalfe, the co-inventor of Ethernet. And we were talking in the airport. And he was going to give the keynote speech. And the keynote speech was going to be about the .com bust. Now, so I started talking to Bob about .com and told him about my wife and what she had done and how she had suggested, which became the dot committees. And when he gave the keynote speech, he actually inserted that story into it. And years later, we actually, my wife and I met him at an MIT dinner. And I introduced him to Natalie and he says, oh, thank you. Now I know where the story came from. But, you know, it sounds like fun, but understanding what the needs of the people are, not the technology. The engineers do a good job at technology. Understanding the needs of the people are what made this standard and what made it, you know, every computer, every toaster has one of these things in it. That's just amazing to me. It's just amazing.
Okay, makes a lot of sense. So how and why did the move happen from, you know, IEEE P802 right into the ISO standard, right? So what drove the decision to do that?
My objective when I went to digital in general, because I was in charge of all standards, was international standards. I'm not very good on timelines, but if I remember correctly, the common market had formed. And I felt that if the common market formed and these European countries got together, then it would be, instead of the United States and their standards up against France or Germany or England,
yep,
it would be against a block. And so one of the things that I was promoting to my boss, the vice president of engineering at Digital, was we have to aim everything to become international standards as quick as possible. And so as soon as 802 was accepted and approved by the IEEE, I said, I'm going to bring it to ISO. I was already a member, I was already involved there. And Bob Donnan from IBM said he's going to bring Token Ring. And so the two of us decided we were going to do this. We sat down with Don Lockery, who was currently chairing 802. Don Lockery was from HP. His background was he had just finished IEEE 488, which was the instrumentation bus.
HBRB.
And he did that at IEC. So Don Lockery and I sat down and said, where internationally should we bring this? Don said, well, IEC is good. I have friends there. I said, ISO is good. I have some friends there. What ended up was a gentleman named Ed Losey, who was the chair of Subcommittee 6, which was the lower 4 layers of the model. He introduced himself to us and said, I'd like you to bring it to my committee. And we said,
whoa, that sounds good.
It's good, but what do you got to offer? Because we're in really closer with IEC. He said, well, I'll tell you what, I can convince my people to work on it, to listen to you. And on top of that, your 802, I'll get you the international number 8802. And Don and I looked and said, that sounds like enough. And so even though Don and I were the ones who set it up, it turned out to be Bob Donnan and I who actually were the members of the committee. And Digital Equipment and IBM spent a lot of money for us to get it to be made into an international standard. And we had problems that you would never think of. The original standard, and it's behind me, was a hard-covered book. And one of the comments against approving it was, it's a hard-covered book. If we make any suggestions, are you going to be able to change the standard? I says, of course. Germany voted against it originally because it wasn't on DIN-sized paper and it wouldn't fit into their lab. I mean, these are the issues that we had to discuss. So there was some technical, but most of it was just working with people. And the other thing is, in order to go to ISO, you have to go through ANSI. And I fortunately was well situated in ANSI. Digital had a lot of money. You make some, you help ANSI out in a contribution here and there, and they expedite the document going. And so I was able to have IEEE allow ANSI to contribute it. Don was, Bob Donnan was very well situated in committees. He had a lot of experience, and we did it. And that was my objective. And we've been involved ever since.
So it was understanding where you want to go and figuring out the path that made the most sense.
And understanding, yes, I always explain to people, keep the objective in mind. And the other part of it is, it's people. The technology will follow. Maybe I brought that up because, my ability in technology wasn't that good. It was better in people. But let's put it this way, it worked.
I fully support that. So just for fun, right? So we all know that Ethernet originally came with fat yellow coax, but thereafter we got cheaper.net. And I was just curious for your points of view as to why we went from that beautiful fat yellow coax with the vampire taps to cheaper.net with the BNCs.
So we got this 10 megabit with a 1/2-inch coax cable, and we got it made into an international standard. It was approved, and the people that I was working with in CSMA CD was a gentleman named Alan Flatman, who at that point was an ICL, and Ingrid from Siemens, who was working with Xerox. She was more in the software, he was more in the hardware, but we became very close. And after we finally got it approved, the three of us ended up, as usual, in a bar. And when we were celebrating, and one of the comments was, you cannot run half-inch coaxial cable around frescoes. I remember that statement.
Frescoes?
So in other words, in the US, most of our computer buildings had raised floors and you run cable under the floor. In Europe, they don't have that. They had to run the cable in the building. And the buildings had, well, jokingly, frescoes, but they didn't have the ability to hide the cable, to bend the cable. I think it had a 16-inch radius, bend radius. So the three of us started talking, and up came the idea that we should try to make the next Ethernet into a thin cable that is more flexible and off the shelf. And so Ingrid and I worked on what the objectives would be. She more technical.
Because you always start with the objectives.
You
work out where you want to go before you start walking.
And I'll tell you, we had to throw away so many of the ones at the half-inch cable. Half-inch cable was impervious to noise. You could put it in an elevator shaft next to motors. There was a lot of things about it that the original people wanted. Ingrid and I felt that wasn't necessary anymore. There probably were uses where we didn't need that quality. And so we assigned Alan, or he assigned himself, to find an off-the-shelf coax cable that would do this. And the rest of it was basically Alan. And he came up with which BNC connectors to use. They had to be military grade. I don't know why, something technical. The length was shorter, again, something to do with resistance. But he basically did most of it. Now, in trying to name it, it turns out that Alan suggested CheaperNet. And I said, well, cheap in the US means low cost, not good. And Alan said, oh, that's not the same meaning in the UK. And so we named it CheaperNet. But when the US finally adopted it, they changed it to ThinWire, if I remember correctly.
ThinNet, yes.
ThinNet. But I always called it CheaperNet. And in fact, at home, that's the system that I used. I liked it. It was very good, but it didn't last that long.
All right. So a quick summary. If you look back in time, Ethernet has had a huge impact on the world. How would you sort of summarize what you think it achieved?
Well, first of all, I think standards achieve a great deal. The standard allows at the lowest level interconnection, or case of VHS tape, an interchange medium, and that's what it did. That the fact that we ended up with two. Token bus dropped out after a while. We ended up with Token Ring and CSMA CD, both of them very good. Marketing chose one versus the other, but standards are the thing that allowed the customer, the market, and it turns out in this particular case, individuals like you and I, to be able to use it at a very competitive cost. And the fact is, it works. You plug it in and it works. And what gets me is, I can't believe how complicated it is to pass data from one point to another over this internet. It is very complicated. And yet, because it's a standard and so many people have implemented it and so many people have improved it, it just makes it work, and it's ubiquitous everywhere. It was Bob Metcalf at one conference, one workshop, said, Ethernet is going to be in every toaster. And I'm sitting there on the panel saying, this guy is out of his mind. Well, he was right and I was wrong. And I think the fact that we made it into a standard gave it the ability to lower the cost. To the point is, you can put it in every toaster. Why is not my problem. I have no idea why one would do it, but it can be done.
The internet connected toaster. So I know that you have moved on to somewhat of a life of leisure, but is there any of the areas of Ethernet development that you're tracking today for interest?
What I'm tracking now is I'm consulting to a company that is trying to improve Ethernet at layer 2. And what they're trying to do, which is I find very interesting, is they're trying to resolve errors, whatever an error may be, at layer 2. And they're saying it's now being done above that, and it'd be much faster if it wasn't done in software. It's done right at the link layer. And I say to them, you should understand that 50 years ago, when we started this, we had telephone lines with lots of errors. And by moving to Ethernet, there were no more errors. And now they're telling me at the speeds that they're working, there are things called errors. It could be a lost packet. It doesn't have to be a burst on the line. But so I'm bringing them history, and I'm enjoying it. And I'm seeing things redone again. So I'm keeping my hand a little bit in standards that way. And I'm the only one left in this group that has been through, modems. When I started, yes, it was a 201A modem, which is 2400 bits per second. And now they're talking about gigabits. Yeah, it's very interesting.
All right. So as a shameless plug for ourselves, right, what do you think of the idea that we're putting together of a set of stories about Ethernet?
I think it's vital because there are people I run into today who don't understand why we should attend meetings and work together, whether it be an international standard, an ANSI, or an IEEE standard, or even one in the company. I can do better. And the answer is, you may be able to individually design something better, but if a group agrees upon it and we make it more useful, then it becomes a better product. And looking at history is the best way of doing it. I mean, you look at how many products only exist because it was a standard. If you take, I don't know if you remember, but we used to have CD-ROMs with music on it.
Yes, and you've seen the color of my hair, right?
Well, some of the audience may not. Somewhere along the way, a small group of 5 people decided maybe we can actually use these CD-ROMs for data interchange, not just music. And they rewrote how a CD-ROM should work. And it was a whole revolution, not an evolution, it's a revolution that all of a sudden every computer had to have an optical disk drive on it. And how is it done? 5 people in a standards committee who said, let's get together from 5 different countries, let's get together. So I'm a very, very strong promoter of standards. And how do you promote standards? History. And this kind of history is better than writing a dense book on the subject.
That makes a lot of sense to me. All right, so let me close up, right? So we appreciated hearing stories today from Gary Robinson, right? Tune in to hear other voice of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore where the technology might go next. Thank you for joining. I'll see you in another episode.
Thank you.